All right, so now we're going to take a look at horizontal and vertical translations, aka the whole graph shifting to the left or to the right. We're still going to use the basic idea of drawing the parent function, then just shifting x and y values, however. Okay, so we have example A, and I should have changed this back into radian mode because that'll be my expectation for you that you're doing all of these with radians. So instead of 60 degrees, we're going to convert this to being pi over 3. Okay. First thing, I'm going to draw my parent function. I'm going to draw a cosine. Give myself my 4 quadrants. That's why we have 4 tick marks. And cosine is the curve that starts off at the top because the cosine of 0 is 1. And so notice that I'm just drawing my curvature shape. Should have gone through this coordinate here. And then we're going to continue it on to the other side. Okay? All right, so now let's actually start to label things. Notice that my a value is 1. That's why this is a y value of 1, and this is why this is a y value of -1. When I have a translation on the inside here, first things first, I need to calculate the period, okay? Because my b value is 1, my period's still going to be 2 pi. It takes 2 pi units in order to cycle back. Now, to calculate the phase shift, I'm going to take this value here of pi over 3 and divide it by my b value of 1. Because my b value is 1, I'm just knowing that pi over 3 is my horizontal translation. Whenever it's negative, I know I'm going pi over 3 units to the right. So now, instead of this x value here being 0, this is actually going to be pi over 3 because this is going to get moved pi over 3 units to the right. We're now going to be starting at the top of my curve at pi over 3. Okay? So now we're going to use the period to fill in the other function. Okay? So the distance between the top of the curve to another top of the curve is 2 pi. So we're essentially going to take pi over 3 and add 2 pi. Might be helpful to give myself a common denominator, so I'm just going to write a side note that this is 6 pi over 3 units. So pi over 3 plus 6 pi over 3 is 7 pi over 3. And now we're going to go halfway between pi over 3 and 7 pi over 3. So I'm essentially looking at what's halfway between 1 and 7. Well, one way of looking at that is the distance between 1 and 7 is 6. Half of 6 is 3. Therefore, I'm just adding 3 pi over 3 to get to the middle. So pi over 3 plus 3 pi over 3 is 4 pi over 3. Okay. Now, what I'm going to be looking at is what's halfway between pi over 3 and 4 pi over 3. This is a little bit harder to do because there's nothing exactly in the middle of 1 and 4 because it's a distance of 3. So like the strategy I gave to you in a previous example in a previous unit is give yourself a bigger denominator. Pi over 3 is really 2 pi over 6, and 4 pi over 3 is really 8 pi over 6. Halfway between 2 pi over 6 and 8 pi over 6, well, that's going to be 5 pi over 6, which is why we have a coordinate of 5 pi over 6. Well, now let's think about what is the distance between coordinates here. The distance between 2 pi over 6 and 5 pi over 6 was 3 pi over 6, or pi over 2. So to get to this guy over here, I'm going to add, again, 3 pi over 6 to 8 pi over 6. 8 pi over 6 plus 3 pi over 6 is 11 pi over 6. Now, because we are no longer centered at 0, we're going to have to go backwards. And so I was adding 3 pi over 6 to go forward, so we're going to subtract to go backwards. So middle value is really 2 pi over 6, and if we subtract 3 pi over 6, that gets me pi over 6, but negative. Okay? Now we have negative pi over 6 minus another 3 pi over 6, which would be negative 4 pi over 6, which simplifies into negative 2 pi over 3. Okay, so that was negative 4 pi over 6. Again, subtract 3 pi over 6, and we get negative 7 pi over 6. Last one, we subtract again 3 pi over 6, and that's negative 10 pi over 6, which reduces to negative 5 pi over 3. Little good way to test your knowledge, okay? what is the distance between pi over 3 and negative pi over 3? Well, that is a total distance, like we had mentioned, of 6 pi over 3, which is our period. So we know we did this problem correctly. All right, so last thing I want for you guys to make sure you understand how to do is your domain and range. So once again, domain, all real numbers. You can plug any value you want into here. Range, we go from -1 to +1. All right, let's take a look at B. Don't know why that's writing with me, but that's okay. We'll just ignore that. All right, so here we go. We're going to draw our sine curve, our parent sine curve. We draw our 4-quadrant tick marks. Here, 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 and here. And give myself my min and max marks just to help me frame it up. At 0, sine is 0, so we always start in the middle. And we work our way up and down and all around, creating the curvature for the sine curve. And then it just gets reflected across the origin to create our backwards motion. First thing I want to do is recognize the fact that our amplitude here is 2. So our maximum y value is 2, and our minimum y value is -2. All right, so now our period, because our b value is 1, we still have a period of 2 pi. To calculate our horizontal shift, we're going to take our c value and divide it by our b value of 1, which is just going to be itself. And because it's positive, we know we're moving to the left by pi over 4 units, which means that our middle value for x is no longer at 0. It's going to be negative pi over 4 because we moved to the left, and essentially our sine curve got moved backwards. Now, one full curve would take me from here to here, and so it should have a distance of 2 pi. Like I recommend, let's give it a common denominator, so that would be 8 pi over 4, not 8, Miss Rudolph. And so we're going to add negative pi over 4 with 8 pi over 4, which gets me a x value of 7 pi over 4. I'm going to use a different strategy in this problem than I did the last problem, so you can just start to pick your preferences. So on the right-hand side of my curve, I added the period. To get to the end point of the left side of my curve, I'm going to subtract my period. So negative pi over 4 minus 8 pi over 4 is negative 9 pi over 4. Okay? All right, the next value I can label is the halfway mark. Let's just keep playing around with the negative side. What's halfway between negative pi over 4 and negative 9 pi over 4? Well, the total distance between negative pi and negative 9 pi is 8 pi, okay, which means half of that is 4 pi. So I'm essentially going to go 4 pi over 4 units to the left of the center, which is why halfway is negative 5 pi over 4, okay? Thankfully, I can continue to play this game of going half and half and half. Halfway between negative pi over 4 and negative 5 pi over 4 is negative 3 pi over 4. And halfway between negative 9 pi over 4 and negative 5 pi over 4 is negative 7 pi over 4. Okay? Now let's work on the positive side. Halfway between negative pi over 4 and negative 7 pi over 4 is going to be 3 pi over 4. Halfway between 3 pi over 4 and 7 pi over 4 will be 5 pi over 4. And then we need to figure out what's halfway between negative pi over 4 and 3 pi over 4, and that would be pi over 4 units. I want to make an observation for you. Notice that halfway between pi over 4 and negative pi over 4 is going to be our next value of 0. So I'm going to clearly label that this is actually where the new y-axis is located. This is the curve that you would actually see if you were to graph this on your graphing calculator here. And actually, looking over here, it's something that I should have approximated. I should have noticed the fact that halfway is pi over 3, behind him is negative pi over 6, so it is approximately right here where your new y-axis is located. Okay? Yay, it's the last one! And fear not, we are going to do more examples in class together because this is definitely a very difficult topic. Alright, so we're now given y is equal to 1/2 sine of theta plus 1. Just like we've been doing, we're going to start off by graphing our parent function. Give myself 4 tick marks representing the 4 quadrants of the unit circle. Give myself a min and a max just to help frame up my curve. Sine starts in the middle, works his way up and down and all around. I'm going to do that to both sides, and I'm trying to be as precise as I can. It's a little hard to do on an iPad, not going to lie to you. All right, so we have an A value of 1/2, okay? So our amplitude is 1/2. But I also have a vertical shift of up 1 unit. All right, so this actually is going to change the location of my midline. So I'm actually first going to adjust this midline. This is no longer a middle y value of 0. This is going to represent a middle y value of +1. And then, to find our new min and max, we're going to go up and down by our amplitude. So 1 plus 1/2 is 1.5, and 1 minus 1/2 is 0.5. Notice that our total height, the distance between 1.5 and 1/2 is 1, and half of that is 1/2. Now because I have no b value, it's just 1, my period is still 2 pi, and because I have no horizontal shift, I'm still centered at 0. So I actually am going to have all the standard quadrant marks and all the standard locations of pi over 2, pi, and 3 pi over 2, and they're going to get reflected across and be -2 pi, -3 pi over 2, -pi, and -pi over 2. And ta-da, my graph is done. Notice I'm not trying to play around with moving the curve itself. It's a lot easier just to move these isolated values. Together in class, we are going to do all 4 transformations. Fear not, we are in this together. All right, so first, before we also do this in class, where we're going to look at another function, let's first try to explain all 4 transformations happening with example 3. All right, so notice that we are given a cosine. So like I've been saying, the very first step to graphing is to first graph your parent function. Giving myself my 4 tick marks, please recall what the 4 tick marks represent. They represent the 4 quadrants on the unit circle. All right, so cosine starts at the top of the curve and works his way down, plotting myself my pivotal points on my unit circle. Essentially, again, these are my 0 degrees, 90 degrees, 180, 270, and 360, as well as the backwards motion. All right, first thing I'm going to worry about is this -6. And so this means that I shift my midline down 6 units. So now this middle y value is -6, okay? Now I have an amplitude of 4, okay? That means if I double that, my total height from my curve should be a total height of 8. In order to achieve that, I'm going to go up 4 and down 4 from my midline. So if I go up 4 units, that would be -2. And if we go down 4 units, that would be -10, okay? Notice that on the y-axis, that means each of my blocks represents 2 units. And so actually I can redraw where the x-axis is actually located. Observation, notice that my curve actually does not touch the x-axis at all. And so we would have no zeros. Just a little fun fact. All right, next thing we're going to do is look at our period and our phase shift, or our horizontal shift. Our b value is factored out, which is why actually we're able just to identify our horizontal shift. But first, let's do period. So 2 pi divided by 1/2. Divided by 1/2 is the same as multiplying by 2, so we get a period of 4 pi. Also, like I said, because our phase shift is present, because our b value is factored out, we essentially don't have to divide by b because the inner b is 1. And so our phase shift is clear to us. We went to the right by pi over 3 units. All right, so we're now going to use our period as well as our horizontal translation. Our new middle x value here is no longer 0. He got shifted to the right by pi over 3 units. Sorry about that. Sonny's getting a little excited because he thinks someone's in our yard. All right, so next thing I need to do is use my period to get to the top of the mountaintop on either side of my graph. So I'm going to use my period of 4 pi because the distance to the top of the mountain is a unit of 4 pi. I'm going to set this actually to having a denominator of 3 just to make my life a little bit easier. So our period of 4 pi actually is 12 pi over 3. So to get to this far end of my x-axis, I'm going to add 12 pi over 3 to pi over 3, getting me 13 pi over 3. To go backwards, I'm going to take away 12 pi over 3. So pi over 3 minus 12 pi over 3, which is negative 11 pi over 3. Next, to find our middle values, we're essentially just using portions. We're essentially just using what is the halfway mark. So on the right-hand side, what's halfway between pi over 3 and 13 pi over 3? Well, that would be 7 pi over 3. All right, now we're on the other side of the graph, and that's going to find us this halfway mark right here. Halfway between pi over 3 and negative 11 pi over 3 is negative 5 pi over 3. Now we're going to try to find these halfway marks. Halfway between pi over 3 and positive 7 pi over 3 is 4 pi over 3. Notice the distance between two of our quadrants, essentially two of our tick marks, is 3 pi over 3 units, or pi units. That's why I can fill this guy in as 10 pi over 3. And now I'm just going to go backwards. We have negative 2 pi over 3. And then if we take away another 3 pi over 3, we have negative 8 pi over 3. And it's a little bit messy, but that's because we're having all these transformations occur at once. Let's do domain and range. I know that's not in your textbook, but that's okay. Domain, all real numbers, because we can plug anything we want in for our value for x or theta. Our range, the lowest value we get to is negative 10, and the highest we get to is negative 2. All right, so now we're going to take a look at this real-world problem, the very last problem. I think I said that 2 pages ago, but that's okay. My mistake. So we have this person whose resting blood pressure is 120 over 80. Okay, that means we have a maximum value of 120 and a minimum value of 80. What the problem just gave us essentially is our high Y value and our low Y value. And halfway between them will be our midline. Well, halfway between 120 and 80 is 100, okay? So 2 parts to the equation that we've just discovered, we still haven't talked about what trig function this is our value for A, as well as our vertical shift. So our value for A is going to be 20, because that's the distance between our midline. And the vertical shift on the outside of our function will be plus 100, because that would have gotten us up to our midline value. The next piece of information provided is that there are 60 beats per minute. All right, so what that just gave us was essentially our period. But then the problem says to write a sine function where we are going in seconds. So if it's 60 beats per second, we need to figure out how many beats occur, how many beats per second there are. And so that's going to be 1 beat per second. So that's actually the period that we are dealing with. And so to figure out what our value is for B, we're going to set this equal to our equation for the period, which is 2 pi over B. Well, it's pretty clear that the only value for B could be is 2 pi. So we have our A, we have our vertical shift, and we have our B. Our equation is going to be a sine function. So we have y equals 20 times sine of 2 pi t. And then on the outside of our sine function, we have plus 100. All right, now let's zoom in and let's actually graph this guy. All right, so sine curve, we're first going to graph the parent function. Mark my quadrants. There they go. Sine curve starts at the middle of my graph, works his way up and down and all around. It really helps to mark these locations when doing your curve. It just makes more precision. Notice I didn't do that though for the backhand side, and I ended up not touching a few of my spots. Okay. All right, so midline, this is now a y value of 100, max value of 120, and mid or low value of 80. Okay, those are not negatives. I should probably clarify. This is a positive, a positive, a positive. All right, which means that our x-axis is very, very, very low. Very low. All right, so now let's actually label our values here. We have no horizontal shift, okay? But we do know that 1 full period occurs in 1 second, okay? So that means that we have 1 full cycle, and that occurs in 1 second. So halfway between 0 and 1 is 1/2, half a second. Halfway between 0 and 1/2 is a fourth. And essentially, you're just noticing that this is a much more exaggerated version of the one that occurs in your textbook. The textbook is showing multiple beats, and so they're extending the graph to go beyond 1 second. All right, this has been your trigonometric functions.